Today I'm going to show you how to make your own DIY circuit board. And we're going to be using a cornflakes cereal packet, some electrical components which you can get from an electronics store, and kitchen foil. Start by cutting up the cereal box so you've got a flat sheet of card, like this. I'm drawing my circuit out on this piece of paper first, so I've got something to work to. The battery will be placed here on the left-hand side. Then there'll be a switch along the top with a motor. Then here we're going to have another two switches, one which operates a light bulb, and one which operates a buzzer. Then along the bottom here we're going to add a variable resistor before completing the circuit. So here's the finished diagram I'm going to be working from. The first thing I'm going to do is make a battery holder for this AA battery. I'm using a strip of cardboard from the cereal packet, placing the battery on and shaping the cardboard into a tray like this. Use some strips of tape to hold it together. And that's our battery holder. To fix it to our circuit board, I'm using some double-sided tape. Stick it to the bottom of the holder and fix it onto the board. Next I'm cutting off a bit more of the cereal box and cutting two strips of cardboard like this, which I'm going to be using as switches. Again I'm using a little bit of double-sided tape and fixing it to the board. This will be our motor switch. And to keep the cardboard switch springing back up, I'm using these self-adhesive felt pads. Cutting off a strip and fixing it under the switch here. This will help to ensure the switch stays open unless it's manually held down. Next I'm taking some kitchen foil, tearing off a strip, and this piece is actually a bit big, so I'm tearing it in half. And we need to fold it over and over so we have a thin strip about 1 centimetre wide. We need to make a whole load of strips like this, and we'll be using them to build the circuit. The first thing we need to do is run some double-sided sticky tape inside and over the edge of the battery holder. Then stick some foil over the tape and up the board. Cut off the excess. And you can see this piece is slightly too short to go over the switch, so we'll use this piece later and use a new length here instead. But first we need to wrap some double-sided tape on the underside of the switch and over the top, like this. Then, starting with your foil, overlap the last piece, run it over the switch, and wrap it around the bottom so it's stuck to the tape. Then cut off any excess. Next, I'm sticking on my double switch below, here. I've already added some double-sided tape, so I'm removing the backing. I'm also adding a strip to join it to the foil above, like this. Then take some more foil and carry on building the circuit. Make sure the foil always overlaps an adjoining piece, so there's no break in the circuit. Cut off any excess foil, and I'm adding some felt pads again. Once you've got this far, you can use some sticky tape over the top of the foil to hold it all down and protect it. But don't tape over the switches. Next, we're going to wire up and fix on the motor. I'm bending over these contacts and fixing on the tin foil by twisting it into a point, poking it through the hole and winding the foil around the contact. I did the same on the other side, so you've got something which looks like this. Then, using a glue gun, I put a line of glue around the outside of the motor and fixed it to the circuit board here. Next we need to complete the switch. So I'm sticking a strip of double-sided tape underneath the switch and fixing the foil to the board like this. Remove any excess, and this is going to be how our switch works. And the motor is now stuck fast and held firmly in place. The next component we're going to add is this buzzer. I'm shortening the wires and stripping the insulation off at the ends. And I'm using some double-sided tape to hold it in place. Next, I'm using tape and foil again to continue building the circuit. And I'm pinching the buzzer wire between layers of foil. Then I'm holding it tightly in place with a strip of tape, making sure the tape doesn't cover the foil underneath the switch, as this would stop the switch being able to make an electrical connection. I did the same on the other side, then continued building the circuit underneath the other switch. And now we're ready to fix on the bulb and holder. I'm removing these connection screws, then using the glue gun to fix it in place. Continue building the circuit, and I used the screws to attach the foil to the bulb holder. Continue with the circuit and hold it in place with more strips of tape. And finally, we're going to use this as a variable resistor along the bottom of the circuit board. We won't need this third pin, so I'm removing it with a set of pliers. I'm bending over one of the pins and attaching the foil in a similar way to how we did previously. I also added some double-sided tape so I can fix it to the board. Placing it here will allow us to increase the resistance in the entire circuit and affect any one of the other components. Finish by connecting the other end of the battery holder to the circuit, making sure the pieces of foil don't touch in the middle. Tidy up the circuit by cutting off any excess foil, and hold it all in place with more tape. I put a length of felt on the motor to help see it spin. Place in a battery, and it's ready to use. Pretty cool, huh? You can see straight away the motor starts to spin. Pressing the switch completes the circuit, and the motor kicks into life. We can use one of the other switches to start one of the other components. This press button means you can tap out tunes on the buzzer. So we've got the motor, the buzzer, and the light bulb. But when I tried turning the light bulb on, there's nothing more than a small glow. I think there's a bit too much resistance in the circuit. So I decided to remove the battery, peel back the foil, and exchange the battery holder for a new one I've made, which holds 2 batteries instead of 1. Now when I press the switch, the bulb lights up nice and bright. Everything now works as it should. What's really cool is we've got this variable resistor, so we can increase the resistance in the circuit and affect our devices. If I turn it whilst using the buzzer, you can hear how it affects the pitch. I can also use it to adjust the speed of the motor, slowing it right down or speeding it up. And of course, if I increase the resistance when the bulb is switched on, it dims the brightness of the bulb. It's a really good fun electronics science project to do at home with kids. You could design a whole host of circuits, and components are easy enough to get hold of at electronics stores or online. If you make it on a different coloured piece of cardboard, the foil circuit will really stand out. I hope you've enjoyed this video. If you want to see more, you can click on the links or take a look at my YouTube channel page. Stay safe, have fun, and as always, thanks for watching.